So welcome once again to the Cosmos Chat podcast. It's me, your host Viraj Bhardwaj, and with me, my co-host Siddharth Sharma. And today we are gonna talk about space radiation with our guest Guadalupe Espinoza Gastelum. And first of all, I want him to introduce himself.
Hi, guys. Well, first of all, thank you so much for having me in this podcast. It's such an honor that I get to be here with you both, Viraj and Siddharth. So I'll do a quick introduction about myself. So my name is Guadalupe Espinoza Gastelum. I am originally from Mexico and currently live in New York City. I am a mechanical, mechatronics, and sustainable energy engineer and a space operations engineer in the making. Also, I am currently training for research missions in suborbital space through the International Institute for Astronautical Sciences, or IIAS. Additionally, I am working in the solar industry, and my passion towards our incredible closest star, the sun, has allowed me to dig deeper into space radiation, and I have found this to be such a fascinating topic that I feel very excited to talk to you guys about.
I must say, space radiation is a very fantastic topic to talk about. And if you have heard our previous episode, like with Tom Carew, who is also an IIAS, a Scientist Astronaut Candidate, so we talked about spaceflight research and mentioned a brief into what is space radiation. So today we are gonna elaborate this topic. And first of all, I want you to agree to give a brief introduction like about what is space radiation and all that.
Yeah, so let me just start off by saying that space travel is hard, dangerous, and full of uncertainties. It has always been and will always be. And one of the biggest challenges on a mission to the moon and onto Mars is protecting the crew from space radiation. On Earth and low Earth orbit, we know that humans are protected by Earth's magnetic field. In deep space, astronauts will be exposed to intense radiation environments where they will be bombarded by high energy in the form of waves or particles, damaging the human body significantly. So recently, I took a course in space physiology through IIAS, and we studied space radiation in depth as one of the most concerning hazards for astronauts' health. And in the words of my professor, Dr. Sithouse, radiation is a mission killer. Part of the reason is that the body cannot adapt to radiation. And the longer an astronaut is in space, the more radiation the astronaut will be exposed to. Too much radiation can have a significant negative effects on human physiology. And this chronic radiation exposure can penetrate the skin, damage DNA, and increase chances of developing cancer and radiation sickness. So that's the space radiation, but let's break this down to understand better what the space radiation is. And we know that radiation comes from three major sources. And I can talk to them about in a minute, but that's basically the whole premise of what the space radiation is.
So you like talked about space radiation and all. So as you said, astronauts have a very major concern about space radiations and all. Um, it's very hard because if we are going into outer space for traveling or something else, then we should have we have to take all the things in our mind. Like we have to make some measures to prevent them or to just reduce their effect. And one of the major thing is space radiation, as you know. So first of all, space radiations like have many biological effects on our body. So if we can talk about biological consequences of space radiations on humans, then it would be very great. It would be very great. So can you like elaborate all the topic or like, the biological consequences on our human body when exposed to space radiation?
Yeah, absolutely. So, before I dive into that topic, I just want to give a full understanding to everybody listening that space radiation I mentioned comes from three major sources, and we need to be able to understand what those sources is because we sometimes have this misunderstanding that there is just radiation out there and that's it. But we need to understand the different types of sources affecting the human body. So the first one is charged particles within the Earth's magnetic field as astronauts embark on their journey into deep space. This dangerous region, known as the Van Allen radiation belts, are which are like two donut-shaped regions encircling Earth, where high-energy particles, mostly electrons and ions, are trapped by the Earth's magnetic field. So this radiation is a kind of weather in space and pose a threat to astronauts and a spacecraft. The second source of radiation is from the sun. The sun is made up of electrically charged particles called plasma. And as this plasma moves, it builds up energy inside its massive magnetic field. And this energy is usually released in two types of explosions. We have solar flares and coronal mass ejections, or CMEs. Solar flares are powerful bursts of radiation erupted from the surface of the sun. And coronal mass ejections are also known as solar storms. And also these are large explosions of plasma from the sun's corona that propagates outward into planetary space. And these solar eruptions send shock waves, also known as solar wind, across the solar system, accelerating particles as they go. And the particles in the solar wind are called solar energetic particles, or SEPs, and they consist mainly of protons and possess a lot of energy and can be very harmful for humans. And as astronauts exit the Earth's magnetic field in their journey to the moon and to Mars, solar energetic particles can bombard the crew with a lot of radiation in such a short period of time. The third source of radiation in space comes from the galactic cosmic rays, or also called GCRs, which are extremely high energy particles traveling at nearly the speed of light and come from exploding stars called supernovas from within our galaxy and possibly further out in the universe. So galactic cosmic rays are more sparse, but also more energetic than solar energetic particles coming from the sun. They include heavier elements and can penetrate through vast amounts of material. So really understanding the rate of galactic cosmic rays help space agencies determine how much time an astronaut can spend in space safely. So now tying this to what you mentioned about risks and biological consequences. So, space radiation is something that you can't really see, you cannot feel, you don't know what you're getting, you don't know that you're getting bombarded, but it's happening. But fortunately, NASA and space agencies do have operational dosimetry and crew personal dosimeters that can be used to measure it. And as a side note, there's a really great way to visualize what I'm saying. There's a TV show called For All Mankind on Apple TV. Specifically, I'll make reference of season 2, episode 1. And the premise of the episode is that there's a solar storm that threatens astronauts on the moon. And it's such a very interesting scenario that really makes me think that, there's this whole event that we have not dealt with in real life yet, but the whole concept of space radiation plays the perfect setup for understanding, what are the effects that humans can have when they deal with this type of external environments. And I must confess that I love the way in which the concept of space radiation was brought to a TV show. So it was really cool. And I don't want to give you guys any spoilers, but yeah, you guys should check out that TV show, specifically that episode. So going back to the biological consequences. So there are many factors that can affect the degree in which radiation damages the human body. These factors include radiation dose, gender, body weight, age, and a host of other factors. Among the most serious problems caused by radiation are damage to all parts of the body, such as the central nervous system, skin, skeletal system, gastrointestinal tract, and blood-forming organs. So in other words, radiation can penetrate skin, damage DNA, as I already mentioned, increase chances of developing cancer, as well as boosting the cataract formation, altered neurogenesis, radiation-induced bone loss, among other health effects. And for the people listening, just as for context, so altered neurogenesis is the disruption of formation of new neurons in the brain.
So Siddharth, do you want to add something in it? Because you are also a pre-medical student and you have much to talk about it.
Yeah, I do. I really agree. And yeah, it's nothing about agreed. Like, okay, definitely it do causes the so not effects when a human body encounter with the solar radiation that from the universe. Definitely, it's not the thing that we are dealing in our day-to-day life basis. So yeah, it's I'm really agreed. But yeah, more than adding something, I have a ton and lots of questions to uh him that okay, when we are talking about the solar radiation, in which context or in which context or scenario we are talking about, like when we are lifting off from earth towards the universe, or when we having space missions going on uh out of the ISS or anything like that. So I just want to know, like when like, because I'm really curious about okay, why aren't we making such kind of things? Like yeah, there are many things like in our ICs and all kind of things that we can have around 50% of much absorptions of radiation. And if yes, then like can we use it as, because yeah, radiation we can have as a form of energy, and yeah, by altering their form of energy we can have say advantage to our missions that we having enough energy after being lifted off. So yeah, I just want to know that in which scenarios we are talking about being uh contact with the solar radiation.
Yeah, no, that's such a great question. So I want you guys to picture the Earth's magnetic field. We know that our ISS, like currently orbiting the Earth around 4 kilometers high, it still finds within the Earth's magnetic field. So that means that our astronauts in low Earth orbit, they're not exposed to the Van Allen radiation belts, because they will have to pass through the magnetic, like exiting the magnetic field, so they will experience this trapped radiation within our um, within our magnetic poles. And as you exit the Earth's magnetic field, you are now entering into a new territory where you have two main sources hitting you. One is coming from the sun, as mentioned, the solar energetic particles, and we talked about solar flares and solar storms. And these two particles are carried into the, what we mentioned, the solar wind, and that is hitting you directly. But at the same time, you have another threat coming to you from a different direction, and this is coming from all these exploding stars from further out from the universe, and these are more powerful. So you have many agents attacking you from different angles, and the whole reasoning behind how space radiation it is such a great topic of research is that we do not have the data yet for how the human body is going to cope in scenarios where humans find themselves in deep space for a long term, because we don't have people living there and we don't have the data yet. But it's been studied that there is so much out there that can harm the human body, but we just don't know how the body is going to react. And yes, so NASA and space agencies have identified these three major sources of radiation um, that need further study, but specifically for long duration missions where the number one priority is the astronauts' safety. It's something that it's being studied at the moment.
Okay. And okay, I get to know about that point. Yeah, it was really great. But yeah, I just have a question, like can't we create a material or kind of things or chamber in which our astronaut can have a lift off from Earth towards the orbit, or say in universe, when we are talking about accepting the Earth's magnetic field. So how about that? Yeah, or is it any kind of materials or kind of chambers are being in development? Because in our high schools there is a point that when we have like they teach us about the ICs and black bodies and uh, black body having irregular surface, that's why it traps the heat and radiations. So can't we make this kind of chambers that can not only trap the radiations from all the sides that is being attacking, and we can have it as a using like seriously, I'm a really fan of a Marvel, and I think Marvel is marvelous. So I am taking a reference of the a suit from the Wakanda. Say you might be knowing about the Black Panther, right? The when the kinetic energy is being absorbed or get contacted with that suit, the whole energy is being in a form of either radiation or kind of a kinetic energy is being stored in that suit, and the man having that suit have a full ability to apply that energy in any direction. So it is any possibilities of using that, and if yes, then okay, what are your suggestion and reviews on that? And if not, then what are the hindrances that that create a hindrance for us to making that kind of things?
Yeah, so NASA has indeed a department called the Space Radiation Laboratory, and basically what this department focuses on is it utilizes the heavy charged particle radiation beam from various components that they already have in their lab to deliver specific doses to the actual like a test that they're running with a goal to determine exposure to radiation during space travel. So so NASA has set limits to based on these studies that they've been doing to help protect the astronauts not only from the short-term effect of radiation but also the long-term health effects. And in order to understand or establish what those limits should be, we need to understand, how radiation is different than the terrestrial radiation. And we know that doses are differently from what we experience here than what we will experience in deep space. And then within the context of the radiation limits, so we need NASA and space agencies have worked on establishing a number for a person to keep a log on it during their exposure to this radiation and still fall within the acceptable standard to not develop any type of health effect in the long run if you're exposed to too much of radiation. And so yeah, so in order to minimize this type of radiation exposure, space agencies and along with NASA have established these career dose limits for astronauts based on age and gender. And exposure values are, this is a fun fact, very interesting. Exposure values are lower for younger astronauts because exposure to larger amounts of radiation early in their careers could present greater health risks during old age. And this means that a younger astronaut should be exposed to less radiation because they have more life to live, and therefore a longer chance to develop health problems across their lifetime. Whereas all astronauts have a much higher radiation limit since they have less life to live or less time to develop cancer or health problems. So this proves that there's no really age limit to go to space, which is pretty interesting, huh? But that's the whole concept and what's been studied. And just to put numbers into what I'm saying, so the typical average radiation for a person on Earth, it's around 3.6 millisieverts per year, which is a small dose. Astronauts aboard the International Space Station receive somewhere between 80 millisieverts to 160 millisieverts for a 6-month stay, depending on solar activity. On the moon, astronauts will experience this radiation exposure around 2.6 times higher than the one that they are currently experiencing on the ISS. And as a result, space agencies need to develop and plan strategically the duration of these future moon missions, keeping in mind that that the time for astronauts on the surface of the moon is more critical than being on the ISS, because you're now more exposed to radiation since the moon does not have any atmosphere. So you have a full exposure of what's coming from the sun and from these exploring stars, as mentioned as GCRs. And so the total amount of radiation expected to affect astronauts will directly be related to the time factor, the solar activity, the amount of and type of radiation shielding used in habitats and spacecrafts, as well as the protection embedded in the spacesuits for spacewalks.
You explained the whole space radiation part and all that, and now we can talk about the countermeasures. Like astronauts are still going in the space, and still some measures are like being taken by the space agencies. And like we have gone to moon. ISS is still with people, with astronauts. So can you talk about countermeasures here about space radiation? That like what measures are being taken, and what could we take in future to prevent space radiation effect on our human body?
Yeah, sure. So currently, the main radiation countermeasure, it comes down to time. So we have to limit the amount of time astronauts are allowed to be in space. But we know that that is not the case, or shouldn't happen, because we need to do these long-term missions. So since future long-term missions to the moon will expose astronauts to deal with radiation, other options can be considered as countermeasures, such as shielding astronauts with materials that are thick enough that can prevent radiation to pass through. But based on lessons learned aboard the International Space Station, the use of hydrogen-rich shielding, such as polyethylene, has been the most utilized material for sleeping quarters and galley, protecting astronauts, and also proven the reduction of the crew's exposure to solar radiation in low Earth orbit is key to reduce health problems. That's why you will hear that astronauts rotate every 6 months, and that's because they don't want to space agencies don't want to compromise the astronaut safety by exposing them for a longer time. But on the moon, we know that there's going to be more radiation. We won't have the Earth magnetic field protecting us, so we need to find other ways to be protected. And another way on the moon is the radiation shield that potentially can be used will have to be very, very thick to prevent galactic cosmic rays and solar energetic particles from penetrating lunar habitats. The operational countermeasure against the radiation will be shielding the habitat with the metal shell of the spacecraft, as well as a lightweight polyethylene layers. And in fact, it's been found that polyethylene is 50% better at shielding solar energetic particles and around 15% better at protecting from galactic cosmic rays as compared to aluminum. Another alternative to radiation protection for astronauts is to find shelter in lava tubes while they find themselves on the moon, since they serve as a natural settlements with enough thick material that can protect astronauts from deadly radiation, especially during high radiation doses resulted from solar storms. And that's what happens in that episode that I mentioned to you guys about For All Mankind, season 2, episode 1. Pretty interesting. But also using water as an insulating layer can prevent radiation, since water is a hydrogen-rich molecule that can absorb radiation. And in addition to the operational countermeasures already discussed, there are also some dietary countermeasures, such as drugs that can be ingested by astronauts, which may reduce the effect of ionizing radiation. So these supplements include antioxidants like vitamin C and vitamin A, as well as pectin fiber from fruits and vegetables. Also, omega-3 rich fish oil may be beneficial to damage from long-term radiation exposure, as well as like diets rich in strawberries, blueberries, kale, spinach, which help prevent neurological damage due to radiation. So these are like the type of countermeasures that NASA and space agencies are currently working on to implement, and it's still something in research, but it's been found that by applying these type of countermeasures can help prevent, reduce that exposure.
Okay, so you talk about, okay, the prevents we can have around. Okay, definitely we are having going to have a solar radiations effects on our human body. So isn't any kind of thing or isn't any kind of methods that totally can eliminate the whole process, like astronaut going through whole process of being into the solar radiation? Like according to you, there are like there should be, or there are cases that okay, why not totally eliminate the whole process of going into the solar radiation kind of things by making either a device or kind of a station or with full of chambers, or say we, as we seen in the science fiction movies, kind of solar shield or from to protect us from the radiation kind of thing. So yeah, I would love to have your opinions upon that.
So yeah, so radiation, as mentioned before, it's the mission killer. So it doesn't matter how much protection we want to come up with to protect our crew. We know that we cannot get away from it. We're still gonna be bombarded by radiation. Our whole goal here is to reduce the time of exposure by making a mission to last less time than expected, and as well as trying to find ways to protect our people traveling in this space, or living and working in on celestial bodies. So we know that we need to find ways to protect the crew, but we cannot find, or there's no way we can avoid any type of radiation, because as I mentioned earlier too, galactic cosmic rays are so powerful. These super electrically charged particles have this ability to pass through anything that they come in contact with. Doesn't matter the type of material. They're just so powerful that they will hit you. And fortunately, galactic cosmic rays do not happen constantly in the same way as the SPEs, or solar energetic particles. So I just put it in perspective. So galactic cosmic rays is also like, if you were to put numbers in it, so 1% of GCRs will be more damaging than 99% of solar energetical particles. So that's how powerful the GCRs are, and that's the type of radiation that we are more concerned about the most, especially because of the electrically charged particle content that is coming from these exploding stars that will have to pass through our cells and materials that are protecting us from that type of radiation. So really, like, it comes to finding ways to reduce that type of exposure. We are still going to be affected, but we're trying to develop a plan to find ways that we can still be effective, explore this space, and we know that deep space is a harsh environment. There's a significant concern for long-term human space travel, and in preparation for this space exploration, deeper space exploration, a mission to Mars, let's say, it will take around 6 to 10 months each way. So we're really talking about a 3-year mission round trip. So this means that there will be more radiation exposure than ever seen before. So NASA and the space agencies are really working to prepare for that. And here is the thing, because there is no available data, and we still are limited on information on human response to radiation for long duration in higher exposure doses. Space agencies are currently developing methods to estimate the risk. And during future moon missions through the Artemis program, NASA will monitor astronauts' exposure to radiation through dosimeters, badges that they will be wearing the whole time they are on the moon. And the whole point of that is that we will be able to collect data and analyze it and come up with strategies to mitigate that through the help of the private sector and finding solutions. Because at the end of the day, NASA's #1 priority is to ensure safety, health, and well-being of astronauts during future long duration missions, both to the moon and to Mars. So that's one of the ways that we prepare for further deep space exploration, by entering into the unknown territory, collecting data, and before we journey into deeper space, we need to find ways to slowly find our ways into that more unknown, by finding the tools and technology and resources we're gonna need along the way, so we can reduce that type of risk.
So you talked about space radiation and its biological consequences. Siddharth also puts a fantastic questions to ask the here, and you answered them like very, like your answers were quite amazing. And we have discussed the whole part of space exploration. We don't have much data, and we don't know how to deal with it very correctly, so that we can colonize space and we can live in space for a long term. But yes, we all are working on it, and we humans are not so easily like gets defeated, and we are like working. Just my voice is correct, right? So we all will work for this. And now we can talk about the future of deep space exploration and also the space colonization, because I'm very much excited about it. Space exploration is a thing which makes every human like fascinated about the space is such a beautiful thing. And going there is just our dream for us, as we all know, because just going into outer space is a very big deal for us. So it's a very very big deal, 100 times difficult uh, to like travel outside the solar system, or even in the solar system to the farthest planets. So these are the things we are like working on it, and we are dreaming of exploring the whole space and colonizing the space and all. So I want to know what are your thinking about the future of space exploration along with the space colonization.
Yeah, sure. So I think, well, first of all, let's start off by talking about the future space flights and astronauts. And so we know that the moon, as mentioned, is going to be a test bed for radiation protection in order for humanity to be prepared for Mars. So the more both the impact and the duration of radiation on the moon are understood through the future of Artemis missions, the more NASA and space agencies can extrapolate that to the length of time that astronauts will be spending in transit and on the surface of another celestial body, such as Mars. In terms of colonization, I think as humans, like exploration is part of our DNA, and we are meant to step into that unknown. The stars are calling, and we must go and explore and seek knowledge for the benefit of all mankind. And I think that's the beauty of coming together as a humanity, as one, and being able to find new territories that we can call home, and especially to bring knowledge back to our planet. Since again, it goes back to the same thing. We are explorers at heart, and it's part of who we are, that we are meant to do this type of things. And with the further development of technology and science, we are now pushing those boundaries and being able to get closer to those places that we have never been before, and that allows a bridge for humans to also find other alternatives in terms of future places that we can visit, and maybe do life at another celestial body. But yes, it all comes down to exploration. It's a part of who we are, and we're just trying to live to our fullest default mode, which is exploring and helping our colony here on Earth. So yes, that's I think the future of space travel and space exploration is very bright these days, especially with the things that I think with the introduction of the private sector changing the way things have been done lately. It allows to have space being a more accessible channel for everybody. So making space available to all people allows it to to close those gaps between, you know, like the things that seem impossible to do, and now having everybody getting interested in space and aiming to explore and to pass beyond that line that we think it is impossible to cross. And yes, it's I think times are changing drastically, and what an amazing time to be part of this generation that we are witnessing all of the things that we thought it was not possible. And yeah, very excited for what the future holds for all of us, and super pumped. I think we will all get to experience those things that, you know, are meant to be explored, you know, through our own eyes. And I think everybody will have that chance to see that.
Something in it, in the space flight and in astronomy, because we are so much interested in it. You can take an example here. I also referred in a previous meeting too, that we humans like just lost a doll, a Barbie doll, into the space, and it shows our interest in space and astronomy. So that's the thing, and we can surely say that we humans are never gonna stop exploring the space and achieving many things in the space exploration and almost in every field. So it was fun to talk with you. I
thank you
really
so much, guys.
Really thank you so much for having a meet with us, and we are really happy to have a meet with you, and we enjoyed the meet, and we got to know many things about space radiation, space exploration. And I'm lacking of words. I have I don't have words to explain how much this. No, it was just interesting. I was not aware of these most topics about space radiations and all. But yes, really thanks to you. So you made me aware of space radiation, and now I'm very much excited to see the future of space exploration. Really, thank you so much for having a meet with me and
Yeah,
with
no,
my co-host.
thank you both so much. Seriously, appreciate it. Appreciate the time.